Hi there, this is Colin. Today I'm going to show you some code, or at least some basic two-dimensional code I put together to enable the tracking of, at least in this case, microrobots. This can actually be implemented for, I don't know, you could probably use this if you had biological samples you wanted to track the movement of on a camera. Basically anything that you have, there's a camera feed in and you want to track the movement of it. This program I like to do in 2 dimensions. I've made some 3-dimensional stuff. I'm not going to be covering that in this video because this is more the simplified version for people who are looking to use this on other applications other than what I've used it for the microrobot tracking. So I'll go ahead and get into it so you can get a better idea. So what this program allows you to do, this famtracking.py script, when you run it, before you run it, you want to first you're going to set the video camera number and then the resolution of the video camera here. In my case, I actually have 2 cameras going. The one I'm talking to you right now, which is camera index 1. My one that's built into my computer is index 0. If you're using other USB plug-in, pluggable cameras, you change the 2. So 2, 3, or the index of the number of the camera you're using. So we'll go ahead and run this to show you what I'm talking about. All right, so the first thing that pops up is this window that asks you to put in this numerical conversion factor in micrometers per pixel. The reason it does this is because for the purposes of this internship, I was working with, on the scale of micrometers, and there's this little process we went through where, okay, when we first put up the camera feed, we zoom in as far as we can, and then we find a known feature size, and then from there we can get the micrometer to pixel conversion factor. So you see here, I'm using this program called ImageJ. Here's off to the right here, the picture that we took of the microrobot I was working with. We zoomed in as far as we could. I know that the distance from the edge to edge here is 100 micrometers. I take a picture of it, I import it to ImageJ, and then from here, I'm able to get the distance in pixels because this allows you it maps the grayscale image value in terms of its intensity and and over distance. So we know from this edge to this edge, that's 100 micrometers. We know, okay, roughly from here to here, that's about the same edges. So we know, okay, that's about 200 micrometers. So we know the conversion factor for this given guy is 0.5 micrometers per pixel. So if I was working with that camera, I put in 0.5 micrometers per pixel, hit OK. As you'll see in a second, I'm going to be talking you through my other video camera. So this will obviously be on a little bit more macro scale. But yeah, first you put in your conversion factor, you see a nice, beautiful picture of yours truly. The next thing you're going to do is you have this cursor, it has this little cross selector. What you're going to do is you're going to left click and drag over the image that you want to track. If for whatever reason you click the wrong area, it's perfectly fine. Left click off, you can reselect it again. Once you've selected the area that you want to track, you're going to hit enter, and then it will allow you to track your object live. So as you see up here, I'm going to slide the window over. This is going to tell you if it's tracking. Up here, top left is the frames per second that you're getting, and then over here, this is the conversion factor because if you put it in correctly, over here you put in the resolution of your camera. So we know, okay, width-wise, this camera's resolution is 1024 pixels in the width, and then some odd number of pixels top to bottom. And then as I move my face, the camera or the OpenCV program tracks it, and we know, okay, if I'm moving over here, this is roughly as it based the origin or does the dimensional tracking based off the top left. This is roughly let's say 100 pixels to the right of this, and then 600 pixels down to the origin of my nose. So then, multiplying the micrometer to pixel, you get my position in micrometers relative to this point. So if I move over here, you can notice the numbers are decreasing. And if I move further away, they're going to both increase and what have you. So yeah, I'm going to quickly show you a video of me doing it with the actual microrobot. I'm going to stop the program. So if I go over here, this is the exact same process, except with the microrobot. So as you see, I run it. In this case, the camera I know that I'm working with, it has a numerical conversion factor of 0.125. I put that in, hit OK. I go ahead and select, this is the Safam microrobot. I select the the end effector, or at least that's the part I want to track here. So I'm tracking this guy. And now as this guy moves, it translates left and right. And I actually get the live readout in terms of micrometers where it is for a given moment. So yeah, that's basically how you interact with the Microrobot. Get your conversion factor, put in your conversion factor, select what you want to use, and then it automatically does the conversion up here. One other thing to note is that this can also work with video. You need to first have a video you want to track. In this case, we have this video one that one of the grad students gave me. They want me to track the position of this video live. How you do that is first, change the resolution here to the resolution of the video, and then you want to copy the file path here. You're gonna go in, you're gonna change this. So I can change the index 0, 1, 2 depending on the camera. I can also put the string in, make sure I have this in string form, and get rid of any errors. And now, if I hit run on this program, I put in the numerical conversion factor. I now select the object I want to track, and then I hit enter, and it all operates just the same. And I'll just loop until you're sick of it. So yeah, this is the really simple script I threw together as part of this program. Actually doesn't look like it loops at all. So you have to keep running it every time, or take snapshots or videos of the video, figure out your own workaround. But yeah, this is the program I put together that enables 2D tracking of these microrobots. Again, this can be applied to anything with a camera feed. And it doesn't necessarily need to be in micrometers. You could actually get better resolution if you scale, let's say, your camera resolution, you're down to let's say the nanometers because you're using a scanning electron microscope. You can actually get better resolution. You just have to put in a different conversion factor with different units. And if you're on the macro scale, let's say you're measuring the movement of an object and that's at the meter scale, your conversion factor is instead in meters per pixel. So yeah, there's the program. Feel free to mess around with it. This is just a minimum viable product. Hopefully I showed you can use the camera and the video feed. Yeah, so have at it.